This is our dining room area. It's right off the kitchen, so I guess you could maybe call it a nook, dining nook. We have a swinging exterior door just off the nook. It's our main way to access the backyard. Doors in dining areas are pretty common, but they can contribute to one of my biggest pet peeves, when you can't use the door because the chairs or table are in the way. One of the best ways to avoid this problem is to use a round dining table. I started looking for round dining tables before we moved into our house last year. The problem is I wanted a pretty big table. I wanted to be able to seat at least 6 or 7 people comfortably. In order for that to happen, that meant I needed a diameter at least 60 inches across. I don't know if you've been shopping for hardwood tables anytime soon, but a round solid hardwood table that size is money. I decided to build my own huge round dining table instead, and I'm going to show you how I did it. I decided to make my tabletop out of the same 8-quarter poplar boards that I used for the floating shelves in my kitchen. 8-quarter is the fancy woodworker way of saying 2 inches thick. Before I started building, I had already milled down the rough faces of my boards, so they ended up about 1 3/4 inches thick by the time I got off all the excess material. I needed to cut my boards down to rough lengths. To give myself a rough idea of how long each board needed to be, I used a measuring tape and a Sharpie to draw a large 60-inch diameter circle on a piece of cardboard. We then started to arrange the boards over the circle I had drawn on the cardboard and marked the boards just outside the circle so we would know where to cut. I used a miter saw to break down the boards to rough lengths, but for a simple job like this, a circular saw would have been fine. Next, we laid out the boards over the circle, and I flipped and rearranged the boards to make sure I liked the way that the grain matched up, and I also paid close attention to make sure I was alternating the growth rings. When you're gluing up an extra large panel of wood, like you would for a tabletop, I'll show you why it's important to alternate the growth rings of your boards. Most of us know that solid wood boards can expand and contract due to humidity and temperature changes. The odds are the wood boards you're using are probably flat sawn. If so, when you look at the ends of your boards, the growth rings of the tree are going to look like arched rainbows. One of the most common ways for a wider width board like the ones I'm using to deform is to cup. Basically, the whole board curves following those growth rings. If I aligned all the boards of my big glue-up panel in the same direction with the growth rings facing the same direction, and those boards decided to cup, the curve would be multiplied across each board, and eventually the panel could end up looking like a potato chip, which is a really difficult, pretty much impossible problem to fix. Now on the other hand, if I alternate the growth rings of my boards when I glue up my big panel, and those boards decide to cup, worst case scenario, I'll end up with a really wavy but somewhat horizontal tabletop. If the waviness was bad enough, I could always plane down the surface on both sides of the tabletop. Admittedly, the tabletop would be thinner than before, but at least I'd be able to fix it and still salvage my wood. Once I had my boards all lined up the way I wanted them to go, I began to mark the locations for joinery. To join the boards of my tabletop together, I'm using this guy. This is a big, fancy-looking, heavy jig, but it's pretty simple. It's called the Beadlock Pro. It's made by Rockler. It's pretty simple. Basically, there's a clamp right here and a sidewall, and you clamp this onto the edge of your wood that you plan on drilling your joinery inside. And then it has this fancy little block, and you drill a series of holes, creating a kind of funny looking mortise. In just a second, I'm going to show you how this is used. This bit of joinery is a little bit more advanced than maybe screws or even dowels, but it is very strong and gives you really professional results. Technically, the method that it uses is a floating mortise and tenon. It's very similar to the Festool domino, if you've ever seen that used before. The difference between a Beadlock Pro and a Festool domino, besides about $900, is the fact that you do have to use your own drill with the Beadlock Pro, and it's a little bit more time consuming. I will say the Beadlock Pro is not super cheap. It is a small investment. It's around $100 for the starter kit. If you plan on cutting joinery on very many projects, $100 is definitely a worthwhile investment though. As I mentioned before, the Beadlock Pro is used for cutting mortises, which will accept a floating tenon. You do this by drilling a series of 3 holes and then you slide the guide block over and drill another 2 holes, which connects the first 3, creating what looks like a fluted mortise. I went through all my boards, drilling mortises into the edges, using those aligned pencil marks which I had made before as a guide. If this seems a little intimidating or is out of your price range, another joinery option would be to use dowels and a doweling jig. There's all sorts of different types of doweling jigs. This is a really basic one. It's basically a block with 2 holes in it and a clear plate that you clamp onto the surface of your wood. You drill from the top. There's all different kinds of doweling jigs. They've been around forever and they work great. There's a reason why dowel joinery has been around for a long time and people still use it today. It's a simple and strong way to create a lot more glue surface when you're joining the edges of your boards together. Once the joinery was all cut, we began moving our boards up on edge so we could prepare them for the big glue up. We began by adding the floating beadlock tenons to the pre-drilled mortises. With an application like this, I like to add a healthy amount of water-based wood glue. The water in the wood glue makes the fibers and the tenons swell up, creating a tighter fit within the mortise. We applied more glue to the exposed edges of the boards and then began pressing them together. A couple of the boards needed a little persuasion with a spare block and a hammer. The boards needed to be held together under pressure while the glue dried, but I only have a couple of clamps over 60 inches long. So we found it easiest to glue up half the tabletop at a time. Then, when each half was firmly laminated together, we only had to worry about clamping and holding together the one seam down the middle. To turn the big square slab into a round tabletop, the plan was to use a router and a simple DIY circle jig. I screwed the circle jig in the center of the underside of the tabletop. I then outfitted my plunge router with a 1/4 inch upcut spiral bit. Plunging about 1/4 inch at a time, I took multiple passes moving the router and circle jig along the panel. For safety and for the quality of the cut, it's really important that you don't try to push small bits like this 1/4 inch spiral bit to cut too much material at once. It's also important to remove sawdust from the groove as you work. Eventually, I made as many passes as I could, and I came up with a problem. My router bit was only long enough to plunge about 1 inch into the wood, which was a major problem since my wood panel was almost 2 inches thick. I came up with what I think is a pretty clever solution. I used a drill and a 1/8 inch diameter drill bit and went around carefully drilling vertical holes through the thickness of the wood all the way around the circular groove. We then flipped the panel over, and all that was left was to use a jigsaw to connect the dots, cutting off the excess part of the panel and giving me a rough circle. I could then follow up with a flush trim router bit, which cleaned up the jagged top part of the circle, making it match the smooth edge which I had cut with a router. We flipped the tabletop over one more time so I could use a router to round over the bottom edge. I started with a 1/4 inch round over bit and then worked my way up to a 3/4 inch round over. The round over on the bottom edge is partly aesthetic and partly functional. The bottom edge of a tabletop sees a lot of wear and tear. Having a wide diameter round over will feel a lot nicer on hands and legs as people sit at the table. At this point, I gave both sides of the tabletop as well as the edge a really good sanding. We moved the top outside and I began to apply finish. I knew I wanted to keep the poplar as pale and blonde as possible, so that meant using a water-based polyurethane. However, the one problem with using a water-based finish is, the first coat you apply will cause the grain of the wood to swell and make it rough. So after laying down one coat of polyurethane, I gave the tabletop a good sanding using 400 grit sandpaper, and then followed up with 3 more additional coats. While I allowed my finish to cure, I began working on the table base.
For the base of my kitchen table, I am using this guy. It is an inexpensive restaurant dining table base. It has a weighted 30-inch base and a 4-inch diameter column. It's designed to support tables up to 60 inches in diameter in a commercial setting, so I think it should hold up to my family okay. I'm trying to avoid using too much black in the kitchen area for design, so this guy needs a coat of paint.
After sanding the restaurant table base, I applied a self-etching primer. I then followed up with 3 coats of a gloss beige colored enamel spray paint. Enamel paints are typically very hard wearing, and the gloss finish will make it easier to clean off things like stuck-on food and footprints. When everything was fully dried, we attached the table base to the underside of the tabletop using screws and moved it into place in our dining room.
I bought this pedestal style 30-inch steel table base from a restaurant supplier online. It said it was supposed to be able to accommodate a 60-inch wide tabletop. I don't think they were planning for someone to add a almost 2-inch thick hardwood tabletop to it. I think it's designed for, like laminate, stuff that you would normally see in a restaurant. It looks okay, but it's not great. Let me show you. You see that? Like, I don't know how it wobbles like crazy. So anytime somebody, reaches across the table or bumps their hip into it, our water spills and it's a big mess. So this has got to go. We need something a lot more beefy.
I guess it's time to roll out the barrel.
I've been thinking for weeks what I could use as a core for the table base, and then I found a guy on Craigslist selling barrels, 55-gallon barrels for $50. What's cool about these ones is they're a little bit thicker sidewall and they don't have those typical ridges you see on most drums. So the idea is, I think I'm going to cut down a few inches off the top and then reinforce that top rim with some plate steel. Don't worry, it's not going to stay this lovely shade of blue very long.
The standard height for a dining table is between 29 and 30 inches tall, so we measured from the bottom of our barrel 27.5 inches. That height, plus our steel mounting plate, plus the thickness of the tabletop would get us just under 30 inches, which is right where a dining table should be. We then used an angle grinder fitted with a cutoff wheel to cut off the top few inches of the barrel. The next step was to add a top plate to help disperse some of the weight of that massive tabletop and to give us a way to actually mount the barrel to the underside of the tabletop. We needed to be able to access the top of the barrel even when the plate was attached. So the first thing I did was to use a compass to mark the center opening. Knowing where the center opening was helped me find the locations for the mounting holes. Instead of creating small circular holes to accommodate the screws, we decided to plan ahead for that pesky old expansion and contraction of the wood and create slots instead. To create the slots, we started by drilling 2 1/4-inch diameter holes next to each other. We then pulled out a fun toy, my husband's oxyacetylene cutting torch, to cut through the small bridge of steel between the holes. Once the tabletop is screwed to the base, the slots will allow the wood boards to expand and contract if they need to, without the screws rigidly holding the boards in place, potentially ripping them apart. Next, we began to cut the large center opening in the top plate. These kind of torches are not great. They leave a pretty messy hole, but they can cut through pretty thick steel and they get the job done. We used welding magnets to hold the circle in place while Bryce was cutting, but apparently they weren't quite strong enough. At this point, I grabbed my angle grinder and started to grind everything. I ground down the rough edge of the center opening, as well as the painted edge on the top of the barrel. We needed to get the steel pretty clean to prepare it for welding. We placed the steel mounting plate on the floor, and then flipped the barrel over, centering it over the cutout. Once we were sure the barrel was centered, I went around the seam making tack welds holding the barrel in place. We then measured the plate and the barrel to make sure that nothing had warped, and then started to apply a bead of weld across the entire seam. At this point, the structure of the new table base was completed, and I started to think about how I wanted to finish it. I recently remodeled my laundry room, including a wood veneered surround for the washer and dryer. I made 2 videos covering the laundry room, so make sure you check those out. I got a little practice applying wood veneer to MDF, and it got me thinking. I started to wonder if I could apply wood veneer to the steel surface of the barrel. I went online and ordered a 4-foot by 8-foot sheet of poplar veneer. I wanted the grain of the veneer to run vertically, like it would if the table base was made out of solid wood boards. Unfortunately, that meant that I was going to have 2 seams somewhere on the barrel. For our first piece of veneer, we measured and cut a strip 27¼ inch tall. I intentionally wanted the veneer a little bit shorter than the height of the barrel to accommodate for the thickness of the welded bead on the top. Before applying the veneer to the barrel, we took it outside so I could paint the mounting plate as well as the rounded bottom lip. We wrapped the first piece of veneer around the barrel for a dry fit and to help us determine the size for the second piece. With the veneer taped in place, I ran a strip of painter's tape across the top edge and made pencil marks to indicate how long the second piece needed to be. We then transferred the strip of tape to a scrap board on top of the veneer and then ascribed the pencil markings onto the veneer to determine the length. We added about 1/2 inch to allow our seams to overlap slightly. Next, I began to tape off areas of the table base that we didn't want covered in contact cement. If you haven't used contact cement before, it's pretty cool stuff. The biggest difference between contact cement and most adhesives is the fact that it's meant to be applied to both surfaces that you plan on sticking together. I go into a lot more detail about contact cement and applying wood veneer in my laundry room makeover video, so make sure you check it out if you're interested in learning more. After applying contact cement to the backside of both pieces of veneer, I applied a healthy coat using a foam roller to the surface of the barrel. I made sure to pay extra close attention to the edges. After pulling off the tape, it was time for the really scary part: applying the veneer. With the way contact cement works, you only get one shot. So we worked really hard to make sure the veneer was running perfectly vertical as I laid down the front edge. Luckily, there was already a seam in the steel wrapping around the barrel, which made my job a lot easier. After the first edge of the veneer was tacked to the metal, Bryce began firmly wrapping the veneer around the curve while I used a tool called a J-roller to apply pressure and to work out bubbles. We slowly worked our way around till the first piece of veneer was securely attached. Next, we brought in the second piece. We matched up factory edges of the veneer and fortunately didn't have too much trouble butting the first seam together. The second seam happened to align with the seam in the steel, so we knew that there was no way to get an effective butt joint. Instead, we decided to slightly overlap the sheets of veneer by about 1/4 inch. The next day, I applied a little bit of wood filler to the seams, and after sanding with 220 grit, you could hardly see the seams at all. Next, we removed all the dust, took the table base outside, and began to apply our final finish. I sprayed on 4 coats of water-based polyurethane to match the tabletop. Once the finish was fully dried, we moved it into place in the dining room. Now, with this particular base, it was super important that we got it placed correctly before we moved in the tabletop. And here's why. I was determined to have absolutely 0 wobble with this second table base. In order for that to happen, we needed to add more weight to the base to offset the super heavy top. This is why we cut the large hole in the mounting plate. We filled up a couple of heavy-duty plastic bags with 100 pounds of sand. We then lowered the sand into the barrel. It seems like 100 pounds will do the job, but the nice thing about this design is, if the table does start to wobble, we can always remove the top and add more weight. We move the wood tabletop into position on top of the base, and then I secure the two together by drilling screws through the slots on the underside of the mounting plate. Ready to see the final product? With this thick, solid hardwood top, this is the kind of table you keep for a while. Even if it gets scratched or damaged from daily family wear and tear, it would be pretty easy for me to sand it down and give it a new coat of finish.
Check it out, no more wobble. My water glasses are celebrating.
Not including the stupid first table base that I never should have bought in the first place, the final table cost me a little under $300. That's a pretty darn good price for a solid hardwood 60-inch dining table.
I'll be honest, I'm kind of surprised the wood veneer actually worked on this metal barrel. Actually, it worked really, really well. So far, I don't have any bubbles or ripples or anything. It adhered really well. I do have one complaint about the appearance though. The poplar veneer that I found was really the only poplar veneer I could find anywhere. And although, the colors match pretty closely, the poplar on the bottom is just really boring. There's not much figuring to it. You can't really see the grain. There's not contrast between the heartwood and sapwood like there is on the solid boards on the top. So because of that, I kind of think from a distance, the bottom looks almost painted, which is a shame because I put in a lot of work for it to look like wood, and if it's gonna look like paint, I could have just painted it. Either way, when you get close up, you can actually see the wood graining and it's very nice.
If you want to see more about how we built our kitchen, I recommend you check out our full Building Modern on a Budget house build series. Bryce and I built an entire custom modern house ourselves, and we go over all the details, including the cost. If you like other types of DIY content, check out this video as well. Would you ever use a recycled food barrel as a kitchen table? Let me know your thoughts in the comment section. And as always, thanks for watching, guys.